Okay, so today we're going to talk about inverse functions. And the nice part about inverse functions is it's a very simple concept. The concept is literally, I switch the domain and range. And if you remember, domain is your x's and range is your y's. So let's say I was given these points and they wanted me to find the inverse of this relation. If they wanted me to find the inverse of this relation, I'm literally just going to go through here and switch the x's and the y's. So instead of 2, 3, I'll have 3, 2. Instead of 1, 5, I'm going to have 5, 1. Instead of 4, 7, I'll have 7, 4. Instead of having negative 3, 2, I'm going to have 2, negative 3. And instead of having 5, 4, I'm going to have 4, 5. So again, literally all you're doing is you're switching the x's and y's. And we can see this in a couple ways. This is if they give us points. In a second, I'll show you how to do it with graphs. And the last way will be with equations. Okay, so let's say they gave me this function, and they want me to graph its inverse. Here's what I'm going to do to graph its inverse. I'm first going to graph it. And every time you want to graph a function, you just want to make an xy chart. Because this isn't an absolute value or something we know, you just get to pick random numbers. The random numbers that I like to pick that make it easiest most times is negative 1, 0, and 1. And then I would just find those points. So if you plug negative 1 in, negative 1 squared is positive 1. Positive 1 times 2 is 2. 2 plus 5 is 7. Plug in 0. 2 times 0 is 0, plus 5 is 5. And then at 1, 1 squared is 1, times 2 is 2, 2 plus 5 is 7. So this was my original function. This is what we called f of x. Now I'm going to find f inverse. Well, f inverse of x would just be these flipped. So I'm going to go through and I'm just going to flip them. So it would be 7, negative 1, 5, 0, and 7, 1. And I would just go through and graph those points. So let's graph those points in blue. 5, 0 would be here. 7, 1 would be here. 7, negative 1 would be here. If you wanted to graph the original function, we can see how it's different. The original function I'll make in red. So the original function would be 1 up 7. So I need more tick marks up here. 1, 2, 3, 4, 5, 6, 7. So it'd be here, here, and here. So you can see how the inverse function kind of flips it, but again, all we're doing for the inverse function is we're switching the x's and the y's. That's it for the inverse function every time. Let's see how we can do it with an equation. Okay, so now they want me to find this inverse function. So they want me to find f of inverse for this thing right here. So again, what you do is you switch its domain and range. And another name for f of x is y. So that's another name for that thing. So when I write this, I am just going to write this function with the x and y switch. So I'll have x equals 4 y minus 5 squared plus 2. I just switched again its x with its y. Now, you've taken its inverse, but you don't have an inverse function because everything always has to be solved for y when you have a function. So we have to basically get y by itself at this point. So the first thing I'm going to do to get y by itself is I'm going to get all the things away from the parentheses. So I'm going to subtract 2 from both sides and get x minus 2 equals 4. because this thing is squared, you can't distribute this 4. So because this thing is squared, you can't distribute this 4 right here. So what I'm going to do is instead of distributing that 4, I'm going to divide by 4 to both sides. So I'm going to have x minus 2 over 4 is equal to y minus 5 squared. And this is my last step. I'm going to get rid of the square root, or I'm going to get rid of the square by taking the square root. Now the tricky part about this is you have to put a plus or minus. And the reason you have to put a plus or minus is because squareds have this weird thing where they do this. 1 squared is 1, or negative 1 squared is 1, and 1 squared is 1. If you ever have a function that makes positive and negative numbers become the same, you have to put a plus or minus. That's why when we had the absolute value functions, we would say, oh, it's plus or minus 5 for my answer. So I'm taking the square root to remove this 2, and I'd get a plus or minus. Now I'm going to have plus or minus the square root of x minus 2 over 4 is equal to y minus 5. I'd add 5. I'd add 5. And my last thing would be that y is equal to 5 plus or minus the square root of x minus 2 all over 4. Again, taking the inverse is a simple concept that can be a little difficult. The simple concept is all I do is switch x and y's. The more complicated thing is solving. Let's see one more solving example. Okay, let's try to find the inverse of this thing. So let's try to find the inverse of this. Again, this means the same as y, and how we find inverses every time is we're just going to switch the x and y's. So I'm just going to switch the x and y's. And so for this thing, I'm going to write x is equal to the square root of y minus 5 plus 2. And again, we've taken its inverse now. We've found its inverse, but we haven't found its inverse function because y has to be solved for. So to solve for y, I'm going to try to get this square root by itself first. So I'm going to minus 2. All of x minus 2 is equal to the square root of y minus 5. Next step that I'll do is I got to get rid of the square root. How you undo a square root is you square both sides. When I square this side, the square root will cancel. And this time I don't have to worry about a plus or minus because the square root of things doesn't have that property. Like the square root of, I should have chose a better number, let's do 9. But the square root of 9 is 3. The square root of negative 9 doesn't exist. So I don't have to worry about that thing of doing plus or minus. So those things go away. I have x minus 2 squared equals y minus 5. Then my last step is add 5 to both sides. So I'd have y equals x minus 2 squared plus 5. And that's it. Again, these behave the same way every single time. You just switch the x and y's.